at SAIL at Pune. Okay. So aside from that as well, during the session itself, if you have any kinds of questions, let me know. But the general question answering or doubt session will be conducted after the session in the last 20-25 minutes itself. Okay. But still, along the way, those specifically who are offline, let me know while explaining any particular topic if you have any questions or doubts over here. Okay. Right. Also, we got a bit familiar with the background of those who are present online. But I would still quickly like to know, like, what is your knowledge towards AI, or what is your background basically? Yes, ma'am, please. Yes. Okay, that's nice. Sure. Yes, ma'am. AML first year. Nice, very nice. Nice, very nice. Yes, sir. Okay. All right, very nice, sir. Okay, very nice. All right. Okay, that's nice. Okay. DBMS practitioner? DBMS, right? AMS. Okay, okay. All right. Very nice to see you and meet you all, by the way. So before going into the AI, now here, the session itself is AI for everyone. So we won't be going too much in deep into the technical knowledge or the mathematics of it. So our aim would be without even the mathematical or much going deeper into the AI, everyone should be able to understand it properly, how different kinds of AI actually work and what are their capabilities and limitations itself. Okay. So first of all, I would like for everyone, like, what is their understanding towards AI itself? Like when you hear this term, artificial intelligence, what is your understanding? Like if you have a system or software or any kind of hardware, how do you decide exactly what is artificial intelligence? To which system we can call artificial intelligence? Yes, anyone? Yes, sir. Uh, Something which is autonomous. Okay, yeah. All right. Anything else? Of course, if you think anything, you don't have to be shy while giving the answers. Totally up to you. I just want to know what is your primary understanding towards this particular terminology itself. All right. So, AI or artificial intelligence, the definition itself or how we perceive this particular word, it has been changing from time to time. So, whatever definition or whatever things, whatever our understanding towards this term is, artificial intelligence, right now, today, it is not set in stone. We understand it because of the how we are perceiving or what is the state of AI right now in our world. So AI, basically, the term itself was coined first from 1956 itself. Okay. So you can see that this particular term is not new or not the invention of our 21st century itself, or not just like, past couple of years. But even though many of the systems, okay, we were able to implement, or whatever the state of AI currently is, the landscape itself, there are a couple of reasons that which were, you can say, the cause of development of artificial intelligence itself. So can you think of it? Like what could be the reasons that we were able to advance in artificial intelligence itself? Specifically, let's say after 2015, 14 and 15. Yes, very, very correct, sir. The amount of processing power we have, that is compute power. It can be your CPUs, your GPUs, TPUs, which are by Google, your NPUs, neural processing units as well. Any other reason you could think of? Right. So another reason is the amount of data we were able to gather. Now, when we are gathering the data, why is it not that we were not able to gather large amount of data? Let's say prior to 1980s or 1970s, basically, or even in 17 or 1800. Can anyone think of the reasons that the amount of data we're having, we can also consider that it is data has become kind of the new oil of today's world because all these technologies, AI, your other fields like data science, machine learning, engineering, okay, all of these fields are booming and we are able to use them because of the availability of the data itself. So, what is the reason that we were able to collect and have this large amount of data? Okay, cloud servers could be one thing. Anything else? Data engine, like, okay, we are able to search on the Google search engines. Okay, that could be one reason. Anything else? Whatever you could think of. Again, don't have to be afraid, like, if the answer is okay or not and stuff, just let it out. Sir, what was your name, sir? Vijay, sir. Okay. So let's say Vijay, sir, maybe one fine morning, he's like praying to God again, to wake up, maybe go to the company. And let's hypothetically, let's say he's not enjoying it very much, let's say nowadays. And he asks God, it would be better if I could like go back in time, maybe 16th and 17th century, we'll be able to see some new things. Although old, but new from his perspective. And maybe understand some of the things about the old world better. Like that. And we will have those days it gracious and generous towards us. And God is like, okay, let's complete his wish. I'm feeling generous today. And he somehow, let's say, teleports him back in 17th or 16th century. Now, Vijay sir thinks I should ask something else if God was going to like, grant it. He says like it is also fine. He is like, quite satisfied as well. He's not picky or greedy, we will say. And now, since he's in this new world, 16th or 17th century, in order to survive, in order to even advance, he first of all need to gather the data, right? Maybe he will try to find out at which place he basically got teleported, maybe which king is ruling at that particular place, which are the nearby villages, what is the culture over here. Okay? All of these things he needs to observe first. And this observation, is it manual or automatic, by the way? Manual. So all the observation he's doing is highly manual. Okay. And obviously, whatever we see, whatever we observe, we cannot remember everything, right? So that is why we try to record things. So let's say he decides to record his observations in some kind of database. And what will be the databases he will be using at that time? What could be the databases in 16th or 17th century? People. Like, will he be writing on people? Books, journals, maybe scriptures, even maybe on the wall of some kind of cave. All of these will be the databases. Okay? Not digitalized, just normal databases. Here you can see even recording all the information on all the observations he has done. That will be done manually as well, right? So because of this manual observation and recording of those observation is very manual here, there is friction. There is a limitation on how much amount of data we are able to collect. Okay. Now, fast forward to now. Let's say morning happens, morning comes, and just suddenly wakes up and understands that all of this was a dream. Right? Now, in today's world, let's say Vijay sir is having or doing something on YouTube, maybe on some kind of browser, maybe watching some kind of tutorial, maybe watching a news on YouTube itself. On Google headquarters, is there a separate person assigned to Vijay sir that your job is to monitor him, observe him, if he is doing like something important or anything, just record it. Is it like that? No. No matter what he is doing, whether it is relevant or irrelevant, whether it is important or not, he is continuously being monitored. Monitored in the sense all the observations which is done is highly automatic in this case. And obviously, despite of what information it is getting, we are able to observe, it's getting recorded into the databases as well, right? So observation and recording of those observation is highly automatic as compared to let's say 16th and 17th century. And this is the main reason that we are able to have this large amount of data. By the statistics itself, if you see up to or by 2010, the globally generated data was around 20 zettabytes, which is very, very huge amount. But it increased in just 11 years till 2021 to 181 zettabytes itself. So directly you can say 8 to 9 times increase in the data collected globally over here. And that is why it was crucial. Not just we were able to get that data, but it was also crucial to utilize that data. And as a result, these fields were able to advance, and now we are able to utilize this huge and vast amount of data as well. Although, also, by the way, to this huge and vast amount of data, we don't just call it data, but we call it as big data over here. Okay. And even though the terminology is quite simple, if we have some small or intermediate level of data, we call it as data. And if we have very huge amount of data, then we are calling it as big data. Even the terminology is quite simple. The amount of complexity, the problems which occur when you are handling big data, it is very, very hard to handle it. And that is why you have some other technologies like Hadoop is Spark is where you store data into multiple clusters, where you also get fault tolerance. That maybe in some situations data may get corrupted, may get accidentally deleted. So you need countermeasures to avoid these kind of scenarios as well. So data and compute, these two are kind of like you can say foundation of any kind of artificial intelligence systems you see today. Without this large amount of data and without the compute itself, it wouldn't have been possible to implement all these things. And the third thing is statistical or mathematical methods going behind the scene. Okay? Although these many of these statistical or mathematical methods were already there from 1900 itself, but we were not able to implement these very high performing or high scale models was because of these reasons itself, compute power and the data itself. Now, back to our original question that I say that AI as a term was first coined in 1956 in Dartmouth exhibition, right? So if let's say, what is your definition of AI? How would you define if let's say someone in third or fourth standard, okay, ask you like, what is AI? How would you tell them? Of course, when I say definition, it is not just definition, but you can state your understanding as well. Yes, ma'am. You guys already like, got into learn about your core subjects since you are from, no, not yet. First year. Common subjects are there. Okay. Still may have some understanding, right? Sir, would you like to contribute? Human beings. All right. So your definition of what you said, it is almost like fairly accurate. But the use of these words, like when you say beyond human beings, okay, or let's say faked or accurate, it is not. It cannot be considered, not at least at this particular point. We'll come to it, like based on the capability, how we can differentiate between different kinds of artificial intelligence itself. Okay. Now, let's say if I give you a machine, okay, or software or some kind of system and hardware. You decide whether this particular thing is artificial intelligence or not. Let's say I give you some kind of app or maybe some kind of machine, and told you you have to figure out whether it is artificially intelligent or no. How would you decide that? Emotions are not there. Okay, that could be one point. But let's say I give you a camera. See, are there any emotions? No. But is it artificial intelligence system? Not really. Right? So anything else you would look for in it? Yes. Yes, yes, obviously they do not have emotions. But emotions is not the only factor we look for, right? When we are deciding whether it is artificially intelligent or not, like that. Yes, anything? Okay. So as long as it is utilizing data, then it can be said that it is artificial intelligence. Okay. So let's say I am giving Excel, let's say old Excel, 2007, 2008. It is able to store the data. It is having access to the data. So is it artificially intelligent? No. Yes, sir. Gathering information, reading. Like, how do you basically define reading itself? Yes. 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 Not exactly the emotional intelligence. It is just reading the data. Yes. Reading the data, not just reading, but it is utilizing that data to learn something. That is what the really part of artificial intelligence is. And that is also why data is very important. Yes. Anything else, sir? All right. Huh. By the way, whatever we are discussing, again, nothing is set in stone. These may change in 2 3 years as well. Okay, everything depends on how the landscape of AI shifts itself completely. Okay, so yes, yes, yes. Which way? Yes, yes. Now, this is a really interesting question, being honest, because you had a couple of bubbles. First, during 2000s, you had this dot-com bubble where every internet company, was getting popular. Like people did not think even for a second that as long as a company have internet or .com in their particular name, people were investing in it. Okay? And later on, everything went down and many people lost the money and stuff. So this was your .com bubble around 2007, 2008. So housing bubble was there. Like many people, I think, invested in real estate and housing, and they also lost the money. And right now, this also AI bubble. Okay, many of the experts and people are kind of predicting that this is also just one of those bubble that it is about to burst. Okay. Now, whatever I will be saying, this again is based on my own opinion, my own observation. It is not the fact because these bubbles themselves are things to be predicted or to be estimate. Okay, not set in stone thing. So the way or the direction we are heading in the AI itself, you'll also see that many of the companies they kind of hype up all these systems. Okay, because if you see from 2021 till now, most of the advancement you will see those are just in chatbot, be it Anthropic, Claude, be it your Google's Gemini, or be it your OpenAI's GPT, or some other Chinese models like DeepSeek is there, Kimi K2 is there, your Queen is there. Most of the advancement is just regarding the chatbots or some image generation models themselves. But the next thing in my perspective, like when you are saying AI, now why AI couldn't, is not similar to the previous bubbles? Because previous bubbles were limited to one particular discipline or one particular field itself. Be it your dot-com bubble, it was just related to internet and tech field. Be it your housing bubble, like around 2007, 2008, it was just regarding your real estate industry. When you are considering AI, because of the nature of it is not just used in your tech field or not just used in your computer science field. It is used in healthcare, it is used in economics, it can be used in education, it is also being used in your farming sectors. And nowadays, growing day by day, which can be and which should be like, the issue that the use in weaponaries, various kinds of drones. So, due to this wide diversity of the use cases of AI, the thing about like AI bubble being bursting, okay, is the chances are very very slim because as long as you're able to utilize it in many different fields, there will always be the use of it. It's just the matter that where or how you're seeing this AI. So if you're just thinking of chatbots, then obviously it is like, worse than a Google. But if you're saying that the whatever capability or natural language understanding it is having, you're able to utilize it in multiple disciplines. Or how you're utilizing it, that is the important thing over here. Hopefully, I answered your question. Yes. 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 I will come to this question, okay? Just in case if I like subtly forget or something, let me remind me as this as well. Because understanding like how this actually works is crucial. Like understanding why human intervention is a must, or why we should not do like there is no human intervention like this. Okay? So just ask like what is your criteria of considering a particular system, whether it is an artificial intelligence or not. Now, this itself has been changing again, nothing set in stone. So, around 1947, computer scientist called as Alan Turing, who is also called as the father of artificial intelligence. One irony is he was called father of artificial intelligence, but he actually died even before the term was officially coined in 1956. So, he stated a test. Okay, in order to check whether a particular system is artificially intelligent or not. Okay, we call it as the Turing test. So in his test, he said that if I'm having a conversation with a particular machine and a human being, same conversation with both of them, and machine is going to respond, human being is going to respond, and if I record this entire conversation and show it to some third person, and if that third person is not able to understand or not able to figure out that this particular response is coming from a machine and this coming from the actual human being, then we can call that particular system as artificially intelligent. Okay. Now, in this case, the main principle behind this was in order to call or in order to consider a particular system artificially intelligent, it is not necessary that it should be able to perceive its external environment. That he's saying, even if a particular system is not able to perceive its surrounding, perceive its environment, still it can be artificially intelligent. Okay, this was the main principle behind this particular test. Now, over the period of years, different implementations were there, and that is why this test also evolved. Okay? And around 1951, people or other scientists also came up with something called as total Turing test, where they said in order to have this intelligence or artificial intelligence, the system needs to be able to perceive its external environment, maybe through sensors or something. Because their reasoning was that this artificial intelligence itself we are trying to mimic human brain. Now when we say human brain, it doesn't have to be like human brain or human intelligence itself. We say that out of one thing, arrogance, or second thing, that to us on Earth itself, we are the most intelligent beings itself. It can be a machine brain, it can be a dolphin brain, it can be an alien brain as well, as long as there is some kind of intelligence over here. Okay. So over here, since artificial intelligence is we're trying to mimic the human intelligence, right? We humans, whatever decisions we make, that is based on how we are perceiving our external environment. Okay. Sir, what was your name again? Yes, Nikhil. All right. So let's say Nikhil sir is having a tea in. Do you like tea, sir? Yes. Okay. Is having a tea one fine evening. Okay. So in this case, he's just like having a tea beside the road, and from afar he sees Polestar or maybe Volkswagen. Okay. And he, which is like, coming at a very like, high speed. Let's say he was also aware with the news and stuff, right? And he says, this car is like, coming at a very high speed, and news I have watched, and there's a very high chance that it may like, run over me as well. And my only salvation will be a 300 words essay, right? So he decides that as soon as he finds it, some processing is going inside his brain, right? And based on that, he may like move out of the way. Okay, so whatever decision he made is based on how he is perceiving his external environment. Okay, similarly, let's say instead of a team, maybe his friend, maybe his some relative, maybe if relative comes, sometimes it is you can say questionable whether he will stay or he will go away. But yeah, let's consider a very good friend, okay? And he will stay, he may like, offer him the tea as well. So whatever he is doing is based on how he is perceiving his external environment, right? And so it is what scientists thought that just like we human beings, we say we are able to take intelligent actions as well, we are able to do intelligent thing as well. It is because we are able to perceive our environment, and based on that, we are going to take decisions. That's why machines should also be able to perceive their environment and then act accordingly. That is why they had this total Turing test. And over the years, again, there were multiple kinds of artificial intelligence system or even in principle were implemented. And that's why this test or to call particular system whether it is artificial intelligence or not, these many tests were implemented and changing over the time. Okay. Although, by the way, these two things, okay, were proposed or these tests were proposed in 1947, in 1951. The first implementation was done much later, around 1966, where they had something called as ELIZA. That was the first chatbot by the IBM itself. Okay. So, also now when we talk about AI, okay, so two kinds of things. When we talk about AI, so pri- priorly there were rule based AI. We also call them as expert systems. Now, in expert system, what was happening that you were hard coding every possible situation, scenarios you could your machine or system may stumble upon. So there was some, you can say, whatever environment you were having, it was predictable or definite environment. Okay. For example, if you're learning to play some game, okay, there are patterns, might be millions of patterns, okay, but still predictable. So things like systems like you might have heard the chase champion at that time, Gary Kasparov, and they built an AI system which actually beat the Gary Kasparov at that time. Actually, first implementation was done at the time Gary Kasparov won, and after a couple of months or an year, it actually beat Gary Kasparov also. He was quite salty about it, this particular thing. But these are, what AI systems were like, around or before 1990s. Okay. And at that time, the hype around these were like, the same hype right now you see around generative AI or agentic AI itself. People thought that it will completely revolutionize the world and stuff, which was in a way was true as well because it was kind of the foundation of whatever we are able to see nowadays. Okay. So these were your expert systems. Generally were implemented in specific kind of problems, or more importantly, like in different kinds of games like chess or Go, where the environment was predictable or definite environment. Okay. The second type of AI is your machine learning. Now, machine learning here, okay, got very, very popular when it came. Prior to, by the way, going towards machine learning, the concepts were already there. But very few people actually believe that it will be useful. And of course, the people who did not believe that machine learning can be a thing, they did not have like, you can say a battle with them, or how uh, let's say not much faith in them. It wasn't like that, but the state we were in was such, because machine learning again depend on three things: data, compute power, and statistical or mathematical methods. Okay, these three things. And at that time, during when machine learning concepts were still like proposed, we did not have a mean to gather very large amount of data. Okay, but later on, machine learning became prominent as we were able to gather more data and utilize these mathematical or statistical methods in order to build our algorithms. We also call machine learning models as mathematical or statistical models because they're based on these particular methods itself. There are different kinds of principles in mathematics, maybe based on some probability. So at that time, you have naive Bayes over there based on some linear algebra, like equation of a straight line. So for that, you have linear regression, maybe converting data to multidimensional data. So for that, you have support vector machines, precisely RBF kernel. So different kinds of things were there. Okay. So in machine learning, to be precise, now when we say machine learning, okay, what we are giving now in machine learning as well, you have multiple types. You have supervised machine learning, unsupervised, and something called as reinforcement learning. Okay, there is also, by the way, semi-supervised learning, but you can consider it a type or not because it is just the combination of supervised and unsupervised itself. And even though reinforcement learning is a type of machine learning itself, nowadays it is actually being used for generative and agentic AI algorithms itself to train them. Okay, we'll come to that as well. Now, when we are saying supervised or unsupervised, it is closely related to how or what kind of data we are giving to the machine. Okay. So, for example, I'll be having two things. I'll be having some kind of input, let's say in this case X, and some kind of output, let's say Y. Okay. So when giving the data, if I'm providing input as well as output to the machine, then we can call it as supervised learning. So in supervised learning, the data we are giving is labeled data. For example, I have various images of various animals, and I label those images as whether this particular image is a cat or not cat. Okay, although we are very fast like that. Uh, right now we have many more and much more capable models over here, but let's assume that. So whether it is cat or not cat. So here we are providing the images, that is our input, and the output, that is labeled, that is whether it is a cat or not cat. All of that to our machine. So machine, what it will do, it doesn't understand what is a cat or dog. It doesn't understand that. But what will understand that if I'm finding these particular patterns, okay, then I'm labeling it as cat. If I'm not finding these patterns, then I'm labeling it as not cat. And based on that, it will learn, and later on, if I provide any image to my machine learning model, it will try and predict whether it is a cat or not cat. That is what we do in supervised machine learning. And many times, types of nowadays, we have this generative AI or large language model, large vision model, they try to do this exact same thing over here. Although the training process differs slightly from machine learning, but this is what is the heart of it. Okay. Understood? Supervised learning. Then we have, yes, yes. Huh. Yes, processing. So in this case, unsupervised learning, we don't have output. Okay, we're just having input and we pass this input to unsupervised learning. So what does it actually learn? It learns the patterns. So let's say if I'm providing some kind of data, okay, let's say I have some values, okay. So considering this is the input data, if I pass it to the machine, in unsupervised learning, what it will do, it will try to find out the patterns in this particular data. So if it sees that there is some similar pattern between this, and this, it will consider it as one group or one cluster. If there is some similar pattern over here between these three, it will consider it as one pattern. So it just understands the pattern and gives you the output. Like if the new point you're giving, in which particular group it will fall into based on this. That is what we do in unsupervised learning. So in supervised learning, by the way, we try to solve two kinds of problem. One is classification and second is regression. How to identify that? So when your output variable, that is this y, if it is numerical or some kind of continuous data, then it falls under regression. If this output variable is categorical or some discrete classes, then that will fall under classification. Okay. For example, sentiment analysis, like you view all the product reviews, maybe finding the reviews of some movies on IMDb sites, right? So in this case, if you want to check what is the sentiment of people, whether it is positive, negative, or neutral, so that will fall under, what do you think? Classification or regression? Classification. Because the output variable or sentiment we are having is categorical in nature. That is why it will be classification. Right? So another example or the machine learning life cycle. Okay. So let's take an example of Alexa or Siri. Okay. For speech recognition. Okay. So everyone familiar with it? That you can basically have a talk or maybe set a timer or like, do some things with them. So you can say that, let's say, the company, how the process goes on. So here, mm, considering this as a supervised problem, okay, how it actually learns to recognize the speech. So what company does in this case that they will be recording multiple different types of speech. Okay. Maybe people saying Alexa, maybe people saying Siri, like that. Okay. This will be speech, audio files. Okay. And based on this speech, your machine will learn to identify this speech, whether this speech one is, let's say, Alexa or not, whether this speech two is, let's say, hello or not. And this is how the learning will be happening over here. Okay. Also, it is almost certain that on the first try, it will not perform well. That is why we have to again and again iterate over it. Okay. So again and again, we have to make it better and better so that many people will be consuming. And maybe after some time, you will try to add multiple features into it. Okay. Now, in considering that when we are saying that it is able to identify this speech, or maybe in general, it is able to have the input and identify what is the output over here. Okay. So, can anyone intuitionally think about it? Like, what do you think? How do we really represent it mathematically? This that when we are saying in machine learning, machine is learning the patterns or maybe the mapping over here of input to output. What exactly or how exactly we can represent it in mathematical terms? Any guesses? Mm, exactly mathematical term. It is very simple, by the way. All of you have learned it, like maybe in ninth, 10th class itself. Not exactly. I mean, these are algorithms itself, right? What do we call that equation? I'm sure everyone knows it, the term. No, no, that is just one type of equation or principle. Yeah, but what do we call it? Even Pythagoras is an equation, but in general terms, what do we call it? Not exactly. Like all of you are like very close. Function. We call it as a function. The mapping between input and output. So basically, when we are saying function, we are representing it in y equals to f of x. Okay. So we are saying y is a function of x. That by applying or implementing some equation where x is there, we are able to figure out what will be the value of y. For example, if I have some x values, 2, 4, 3, 5, and output y values, let's say 4, 8, 6, and let's say 11. Okay. In this case, what do you think? What should be the function? Y is equal to what will be the function? 2x, right? These are our actual values, right? So, what machine learning model does, it will learn on this particular data. When we give my machine learning model this particular data, it will figure out this is the mapping of y and y to x over here. Right? But here you can see that let's say if you do, and if I give x values to my machine learning model and will and tell it predict y. Here what it will predict based on that 4, 2x means here it will predict 8, here it will predict 6, and here what it will predict. But is it the correct thing? No. Okay. So always remember when we are considering these algorithms with machine learning, neural network will come to this or generative AI algorithms or this basically large language model, large vision models. Those are never 100% accurate. That is because here the mapping we are trying to find out is designed or we reach this particular hypothesis or conclusion in a way where the differences are minimum, overall difference. That is how we reach at this particular point. Okay. Yeah. So as you said, sir, that it is as long as it is 100% accurate or 100% correct. That is why I'm saying no machine learning algorithm, no LLM, no large vision model, no deep learning model is 100% accurate. Okay. That is also why you'll see one of the disadvantage of AI towards the humanity itself. Couple of days ago, this war is going on, right? Between Israel, Iran, and US. Now, US used drones there and bombed that entire place over there where there was a school, okay, of little girls. So they started saying that it is the fault of AI, that this particular area, which particular area to bomb or which particular area to attack, it is decided by AI and we were just attacking. So one disadvantage is or one dangerous thing about AI is that even no matter what response it is giving, there is no accountability. They like US, I mean, consider bombing the entire school of small girls, right? They are directly blaming AI without taking the accountability. Who to blame them? Okay. So that is why also to your question, human intervention is necessary. Because even though if AI, let's say in this scenario, considering that this particular area you should bomb at the end, who should have the final say? We humans over here. Okay. Because without human intervention, maybe some sensitive information of yours may get leaked online publicly. Maybe your account details, maybe it may even do the payment of something over there like this. That is why we need something called as human in the loop. This is the terminology itself, by the way, when we build our effective agents there, AI agents there, that we need some manual intervention so that our AI system itself doesn't go haywire or will be able to work efficiently. Okay. So, any questions so far, by the way? All right. Now, we saw that for AI, we have machine learning as the subset, right? Now, in machine learning, we saw that we needed three things: data, compute power, and our statistical or mathematical method itself. So, machine learning, these algorithms were improving as we are increasing the data. Because as we increase the data, we are kind of assuming that we are increasing the nuances, we are increasing the patterns in that data, right? And your machine learning will learn from that data. But what was happening that even though we are increasing the data, this increase in the accuracy of machine learning algorithm is not exponential. Okay, means it does after a certain point, the accuracy of machine learning models will become stagnant. Okay, even if you increase the data, this accuracy will not increase. So kind of like this. If I draw the graph, okay, so let's say on the x-axis we have data, on the y-axis we have accuracy of the algorithm. So for machine learning, as we increase the data, the accuracy will increase. But after a certain point, this accuracy will become stagnant. And that is why we needed something else. Because we can see that in today's digitalized world, we're able to gather very large amount of data itself. Okay. But we don't just want to gather this data, we want to actually utilize this data as well. Right. And that is why we have another field called as deep learning. या फिर you can call it as deep neural network. Okay, so deep learning algorithms or deep neural network, here you will see that if you have less amount of data, they may not perform as good as your machine learning algorithm, even maybe worse than that. And as you keep on increasing the data, then accuracy will keep on increasing as well. So that is why we have this particular field called as deep learning or deep neural network over here. Okay. So now, deep learning, this field itself is very closely related to how human brains work. Now, one more thing, even though we say that deep neural network or deep learning, we are trying to mimic the working of the human brain itself. Okay, but how it actually works is nowhere close to how our human brain actually works. Okay, in real. Okay, yeah, we are trying to mimic what kind of things our human brain is capable of, but still, to this day, scientists are not able to find out, at least not publicly, that how brain actually works, how these electric signals basically convert, converted into the actions, emotions, maybe the thinking power itself. Okay, so in deep neural network, you are able to do all of this. And almost all the things you see now, generative AI, agentic AI, those are very closely related to deep learning itself. Okay. So you can see these new fields like generative AI, agentic AI. Okay. All of these fields are very closely related to deep learning as well as machine learning. Okay. So these things are subset of your deep learning and machine learning combiningly over there. Now, in deep neural network, there are multiple kinds of deep neural network as well. You have traditionally NN, that is a simple kind of neural network which is actually working really good on the structured data. Means as long as you have data in the tabular form, if you do the necessary pre-processing there, you will be able to do or implement NN. For your image data, you have something called as CNN. There are various architectures of CNN as well. For text data, you had recurrent neural networks or LSTMs or GROW all of these things. Okay. Now, over the years, in 2017, there was one architecture of deep neural network itself called as transformers. Okay. And this architecture completely revolutionized the field of AI. Okay. The researchers themselves, by the way, at that time did not know that transformers will be this much helpful. Okay. And later on, the emergence of models like GPT, your BERT, T5, okay, these emerge because of this transformers models as well. But again, nothing but neural network models, encoder decoder architecture. Of course, if you're not familiar with these terms, that is completely okay. So because we ourselves won't be going into too much into the technical, but hopefully by this you at least understood the landscape of AI, like where AI actually began and where we are actually heading towards now. Okay, done so far. Any questions over it? No. So shifting towards a bit less technical thing. Now, yes, difference. Yes. We'll be going in a bit depth of generative AI as well, but I'll still give you the overview. Okay. Now, traditional ML, okay, or traditional neural network, what it was doing, or we also call it as discriminative AI. Okay. Now, here, what we were doing that we had some kind of input and we were learning to predict the output over here. So what output we are getting is fixed. Maybe some kind of S no type, maybe sentiments, positive, negative, neutral, maybe some kind of salary as well. Okay, this is discriminative AI. Okay, so where your output is fixed, set whatever the set of possible probabilities or possible classes you are getting giving, it is only going to predict that. In your generative AI, if you provide it input, let's say whatever data you're training it on, it is able to generate new things. That is what generative AI is based on probability distribution. One important, very important thing that all of these things are fascinating, okay? But how they work more than this, they actually work is more fascinating because, like, think about it. Like you, as we understand what we are talking, we understand the context the other person is saying something from. Okay, but how these models are able to understand or get the context of what we are saying through these mathematical methods itself is very fascinating. Okay, that is why I said how they work. More than that, they actually work is fascinating or like magical. So in generative AI, from the data we are providing to our model, it is able to generate new data, maybe new words, maybe new images itself, maybe new voice itself. Okay, like that. That is generative AI. In agentic AI, mm, in agentic AI, they're able to complete a task or a goal. Means in generative AI, it is just responding to you. For example, I asked that I want to have 1 week trip to, let's say, Arunachal. Okay. So, what could be the places which I should visit? Can you plan the trip for me? So, it will like really nicely give me different places which are there in the Arunachal state. Maybe plan out like I should go at this particular time, or maybe I should take this particular flight. Okay, from let's say Mumbai or Delhi. Okay, but it will not do that if I told it book a flight for me. Okay, book a nearby hotels in Arunachal. It won't be able to do it. So, in short, you can say agentic AI is nothing but generative AI or this large language model we talk about there on steroids, or you can say we are giving it hands and legs over here. So, when we say hands and legs, this is kind of like we are giving it access of the tools, some kind of APIs or some kind of functions. That's it, nothing else. Understood the difference? So we'll see a bit in depth, like what is generative AI a bit later. Now, considering this, I also would like to know. Now, we understood what is AI itself. Okay, can you yourself state couple of things which you like, in day-to-day life, which can be considered AI? You can think about it for a minute. What your system, software you use, okay, or things, machinery. Which of them you can consider AI? Hmm. Yes, yes, that is also AI. Or sometimes in some offices, what they do that since you get a lot of emails, they can figure out or they can have like separate spam emails or advertisement emails from the actual emails. So spam or ham you can separate through that as well. So that is an AI. Correct? Anything else? Yes, ma'am. What do you think? I'm sure every one of you use some kind of AI nowadays at least on day-to-day basis. Even Google Pay itself, the application is not AI, or at least not on your end. So maybe kind of like let's say this bankings, okay, they can implement AI. So you have the implementation of unsupervised learning, like fault detection, not fault detection, fraud detection. Like if they find out there is some unusual traffic from your side or unusual amount withdrawal from your side, so they can pin that out, point that out, and you may get a call, like whether it was really you who withdrew the money, who made the transaction or not. Sometimes you do that. So this side of it is AI. They implemented systems. There are also many of the bank systems where when you go to apply loan, okay, so they have systems installed there itself in that particular zone. Like based on your conversation itself, that particular system is able to tell whether you will be able to pay back your loan or not, like that. Not in India, at least not up to that extent, but in foreign countries, this kind of systems are there. That based on your conversation, what words you are using, how you are using them, okay? Based on that, it is able to tell whether you will be able to pay the loan or not. It again, yes, yes, they have implemented it. Yes, yes. Yes. So like that, or you if you give your details, like what is your occupation, whether you have a car or not, how many family members are there. Based on that also, they can check whether you will be able to paying the loan on time or not. Like that. Yes. Anyone else? Yes. 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 Actually, there is a growing need, or at least use, in agriculture sector as well. Yes. All right. Agriculture sector as well. Like crop disease detection based on the leaf of the plant. Maybe how much amount of fertilizer we should use. So all these kind of things are slowly getting implemented in the agriculture field itself. Okay. Now some of the examples are here, like Netflix. Can anyone tell me how this AI is implemented in Netflix or maybe some other e-commerce site like Amazon, maybe search said Reels over there, maybe Facebook Reels or YouTube or Instagram. How the AI system is implemented there? this? Anyone? What do you think? Collect data is necessary, right? These things. This is very closely related to what you said, that it is able to understand the emotional intelligence, right? Yeah. It doesn't exactly understands the emotions, but it understands the data like that. Our emotions itself is becoming the data nowadays. Interest? Yeah. So in this case, they have a specific term called as recommender systems. Okay. So what these recommender systems are based on your behaviors, how which reels you are using, watching, how much time you are spending, all these things it analyzes, and based on that, it suggests you similar content. For example, again, there are different kinds of recommender systems. So a recommender system used in Amazon might be different than in Netflix, might be different from Instagram, like that. All these companies, they have their own algorithm, and not necessarily they are not publicly available. For example, like all of these things, okay, be it Netflix, YouTube, Instagram, what is their main goal? That you should spend as much time as possible on their platform. They don't really care whether you are giving someone else the time or not, whether you are doing your work or not. They just want that we want to make profit, and to get the profit, many users should be spending much of their time on our platform, right? So, one example could be, let's say there are two people, okay, and the algorithm found out that both of them are having similar kind of interest, have watched similar kind of shows on, let's say, Netflix or Amazon Prime. But it finds that one particular person watched a show which this person have not watched it yet. Okay, so it can suggest that particular movie or that particular show to other person as well. Considering there's a high chance that this particular person will like this particular show which we're suggesting them. This is what recommended systems are. So things like Netflix, YouTube, everywhere, like they are implementing these recommended systems. Even if you see Amazon, okay, so around 20 to 30% of the revenue increase is just because of these recommended systems. Like on the home page, you see the recommended items. Maybe if you purchase the item, it also shows like this particular item will go with this. So many people will select or choose to buy it as well. Okay. Another thing, Gmail, your emails to identify which are the spam and not spam messages. So here also, like traditional machine learning can also be used for these kind of tasks. Okay. Then your Instagram curates your feed based on your interest and engagement. Your Google Maps. Now you'll see in Google Maps, many times you may feel like the location is quite close by. So why is it like showing you 20 minutes or 30 minutes? Or sometimes location is quite like very far away, but it shows very like less amount of time than usual. And even though you doubt it, but at the end of the day, it will be maximum off. Okay, the like just hardly like 2 to 3 minutes here and there. So it's actually based on the traffic condition, your current speed, based on everything, it calculates how much time it will be required for arriving at your destination. So there also you have this implementation. Okay. So AI is everywhere in your daily life, and today we will basically demystify how it works and unlock its potential. So again, what is AI? Here, through simple visual, you can say we have a brain. This brain is your AI system. Okay. So kind of like this application you see. Okay. So not entire application is artificially intelligent, but we have a brain just like to our entire body. Everything is gets operated from the central brain itself, right? Similarly, we will be having a brain. So basically AI systems which mimic human thinking process. In this case, you also do something called as pattern recognition. So it identifies patterns in the data, like recognizing faces or voices over here. Learning from the data, they improve accuracy by learning from the data. So as much as data we are giving, new data we are giving, they're able to learn from it and improve themselves as well. So just like you learn to recognize faces, Missing thousands of them. AI learns patterns from massive amount of data. It's not magic, it's math and statistics scaled up over here. For example, now one quick uh, example we can take. So even for images, it learns to recognize patterns. Okay. Now, traditionally, you would have to build an entire convolution neural network architecture to recognize faces or recognize a particular object and stuff. But there is this one very interesting tool called Teachable Machine by Google. If you want to just directly build a model based image recognition based model, you can use this particular tool as well. Okay. So let's see. What I'll do, I will build one particular model which will recognize a mobile phone and let's say a mouse, okay, like this. Now, in this case, we are just doing it on a way. So otherwise, it would be advisable that we have different angles of the phone, different kinds of mobile phones, different colors and size of mobile phones or the mouse as well. But here I will just use two of them. Okay. So, or instead of a mouse, I will just take pen. So it is collecting the samples around 205. Okay. We will call it as pen. Okay. Class 2. Just a second. Okay. We'll call it as say, mo- and you can do it on any kind of images. Okay. And based on this, I will train a model. Here again, they have generally implemented different architecture of CNN itself. Okay. So you can say, see, it is preparing the training data. All right. So now, of course, I'm holding nothing. It's still saying pen. So that is why I also said no machine learning model is 100% accurate. Now let's say if I'm holding pen and here at the bottom, you can see it is also showing how much sure it is. So probabilistic models are there because when I'm saying pen or mobile, I just don't want to see whether it is that or not. Okay. I also want to see the probability. So as long as I'm having this angle, you can see it is able to recognize it. But as I tilt or give different angles, it will get confused as well. Of course, that is because this data itself is not curated. Okay. So let's say mobile phone, 100%. Maybe let's say if I try to give graphic tablet, what do you think? What it will predict it? Mobile phone, I think. Yes. Okay. So all this kind of thing you can do. Again, these models where you have to train manually and stuff, from here you can actually export the entire model as well. Now, whatever models learnings are, we exactly call them as learnable parameters. Okay? So all these models, large language models, you see Gemini, GPT, your Quen, okay? All these models, they whatever they learn, these are your learnable parameters, and that is the main output or main thing to learn. Okay, so you can export the entire model where it has learned the possible learnable parameters from my particular little experiment over here. Okay. So, So, as I said, how AI learns, there are three steps. First step is training itself, which we talked about, and in the training, it will learn the function. Now, the function is very important because if you see our entire universe, we can actually describe it as a function. We can understand almost anything and everything through universe, through this function about universe. Even if you see the famous Einstein's equation, E equals to mc square for relativity, right? What is it? Nothing but a function. But we were able to understand much about the universe, specifically that C, that is the time constant. Okay, we were able to understand, like when we say one day over here in Earth might be 10 days in some other planet, maybe 10 days over in some other planet might be 10 years on Earth. Why we are able to understand? Because this simple equation, E equals to mc square. So in universe, all the things you can actually notify, through these functions. Some functions are very easy, like your third or fourth standard students are also able to understand. Some functions are very, very complex, which we yet are still yet to find them. Okay. So one more difference between machine learning and deep neural network is that in machine learning, whatever function we are finding, okay, those are based on some statistical or mathematical principles. Okay. And only based on that also it will create those functions. But in deep neural network, in deep learning, it is also able to identify very complex functions as well. Very complex functions as well. That is why deep neural networks are so powerful. And this is still by knowing, like, we still don't know how our human brain works. Now, understand, like, if we knew how exactly, like, we are able to basically convert this electrical signals to actions, to emotions, and then, like, we figure out how to mathematically, imitate them, then we can again uh, increase the power of deep neural networks themselves. ठीक है? So, also based on capability, we talked about there are different kinds of AI. We talked about rule-based AI and machine learning. Now, based on capability as well, there are three categories over here: ANI, AGI, and ASI. So, this is artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Okay. This is based on the capability. Now, what do you think? At which particular state are we in? Yes? Geographically, you're talking. No, no, this is capability. Right now, like, uh, considering the world, like, at which particular state are we in of capability of AI? What is the capability of current AI systems? General. General. I'll also like describe artificial narrow intelligence basically means these artificial intelligence systems, those are able to perform one or couple of tasks really good as compared to human beings. Means, and in AGI, we're considering your AI systems are able to perform and do everything a human can do. ASI means beyond human capabilities. Narrow? Yes, we are in narrow stage. And you will see all these companies, be it OpenAI, Google, Anthropic, or any other, okay, these AI companies, those are having the race towards AGI itself in order to achieve AGI first. Not just these US-based company, but also Chinese-based companies as well, like your Quen, your DeepSeek, and everything. Okay, right now, and the way things are going, we may be close or we may be very far away from the AGI itself. And although we're saying that AGI is something where, like, your AI systems are able to do everything a human being can do, that is our understanding or that is what we are calling it. So May again, the definition itself may change again over the few years. Okay. And because of the hype itself, you can say there are lots of truth, but lots of false information as well from very big companies. So this is the difference between three categories of AI system based on the capabilities. Understood? Yeah. So this is your AI family tree. You have artificial intelligence, which is your vast domain. You have machine learning, you have deep learning, and you have your generative AI or agentic AI there. So here you can see there is a very good hierarchy over here. Now, now AI, as I said, is when I talk that AI is not same as the prior bubbles you had because there are multiple use cases. It can be used in multiple domains as well. Like for finance, you can use it for fraud detection. Like AI identifies suspicious transaction in milliseconds. Suspicious transaction, maybe even someone trying to hack a particular account, it can actually identify there is an anomaly in the system and it can figure it out. Even in there is growing use of AI in healthcare as well, at least in the initial phases. So they also implemented AI like in stethoscope as well that based on the heartbeats, okay, whether it is able to diagnose the patient or not properly, reading different kinds of X-ray images or reports over there, okay. So they can analyze medical images faster than human radiologists, improves diagnosis accuracy by 40% itself. So here we still would be, at least nowadays, for now, we still would be believing or having more trust towards actual human being when it comes to healthcare